Good day to all. This will be our discussions involving interest rates, empirical properties. So basically the properties of interest rates that are to be discussed here are formulaic in nature, but of course based on certain concepts. Now, we are going to divide this lengthy chapter into three parts. So make sure to stay tuned with the updates. All right, so let's begin immediately for interest rates discussions. For the first one, we have to have a review of the nominal interest rate, which is basically the interest rate that is given at face amount or value and is based on the loan contract. So example, suppose you take out a $1,000 loan today and you agree to repay the loan with a $1,050 payment in 1 year. So basically, all other things being constant or ceteris or cateris paribus in economics, there is a difference of $50, a growth of that. And that is because of the interest. And because this is a loans payable, so basically this interest is an expense or interest expense. And with that, we have the interest, which is the difference between the face value and the principal. So $1,050 minus $1,000 equals $50. And to compute the interest rate, especially for this one, which is very straightforward, and take note, this is time of 1 year. And we also have to recall that to compute interest, that is basically the principal times rate times time, and time is 1. Any number multiplied to 1 equals the number. So that will be our principal and the rate. So to get the rate, which is to be squeezed, if we are going to substitute that with our formula, so basically our rate would be the interest divided by the principal. Or we can just say that if it is I equals PRT, so to get P, that is actually, of course, I over RT. Or if you're going to get the R, so that would be interest over PT. And time is 1. So that's $50 divided by $1,000 because it is the rate that is missing. And that's 0.05 or 5% per year. This is the 1 year spot rate. As said, spot rate is the rate that is current or the fair market value of the interest, which is being talked here. In order for us to get the interest, there will always be a time period. Otherwise, there wouldn't be any interest at all. Remember, I equals PRT. If T is 0, so loss of multiplication, the answer would be 0 for interest. Therefore, there should be a passage of time before we get interest. And I think that is basic and fundamental for the understanding of this one. All other things being constant again, ceteris paribus or cateris paribus, it is a must that only interest and the passage of time, the interest rate, of course, and basically on the passage of time focus will be around or there. Next, on annualizing. For this one, normally the rates that we are going to get would be periodic. It would depend upon the contract. It could be monthly, it could be quarterly, it could be semi-annually. So with that, we can basically annualize by dividing it with our factor. So just a basic example, let's say the rate is 10% and quarterly. So basically we just have to gross up by dividing 10,000 with our, for example, 4 months. So 4 months is of course like a third of a year, but quarterly is 3 months, right? So let's just focus with example, which is quarterly first, and then we will have the 4 months. Anyway, so let's just say 10% is quarterly, so that is 3 months. So 10% divided by the quantity 3 over 12. 3 over 12 is basically 25%. So using your calculators there, 0.10 divided by 0.25. So in other words, 40% is the annualized rate. If we say 4 months, so still that's 4 over 12. So 0.10 divided by 4 over 12, and that is 30% if you are going to compute that. So from 10%, which is good for 4 months, we can gross up to become annualized. In this example on this slide, suppose that you invest $1 at a quarterly interest rate of 2%. So what is your annual return? If you're going to look at the illustration, it earns 0.02 of a dollar after the end of a certain quarter. So example, 1 times 1.02 equals 1.02 times another 1.02 equals 1.04, and so on and so forth. We can actually recheck the values. So you can pause this part here and recheck the amounts. And 1.06 times 1.02, that would be 1.082. Now, that is basically the cumulative interest that we have. So if we simply multiply 1.024 times, we are going to get 1.082. And to compute our respective interest rate, so that would be the total amount, the future value, or the sum, 1.082 minus 1. So we get 0.082 divided by 1. So a while ago, again, interest divided by principal. So 0.082 divided by 1 equals 8.2%. So that's how we are going to get that. And an approximation would be, it's not exact though, 0.02 times 4. 0.02 is for the quarter, times 4, that is 8%. It's close to 8.2%. However, because this is a compounding effect, so that wouldn't be suggested. That is a good approximation and would be exactly normally equal if ever the interest is straight, like again, I equals PRT, not like this one, which is a compounding effect. All right, so this is just a review of your mathematics discussions. What about suppose you earn a cumulative interest rate of 5% over a 4-year period? What is your annualized return? This is now going to be mathematical in this sense, but let's just take note that the 5% is the total interest over the 4 period. And this is, for example, a compounding effect. So money earns interest, and the interest that is earned the next time would be based on the money plus the interest. So money earns interest, and the interest that is earned earns further interest, and so on and so forth. So with that, using our formula in which to get the next value after a year, for example, that is going to be the X amount times 1 plus I. I is the periodic interest rate. And then the return is unknown, of course. So same, whatever will be the amount, that will be multiplied with 1 plus the I, in which the I is question mark, and so on and so forth. So to do this, it's going to be 1 plus I, and then multiplied 4 times for a 4-year period equals 1.05. And then remember, this is going to be the sum of the 4 in terms of exponent, right? So in laws of exponents, if we are going to multiply these items enclosed in parentheses, remember, it's just going to result to the power of 4. So we just have to add the exponents. 1 plus 1 plus 1 plus 1. So 1 plus I and close in parentheses to the power of 4 equals 1.05. And we have to get the fourth root now of 1.05 to basically extract that and remove the parentheses for 1 plus I. And whatever is the result here, so 1.05, the fourth root of that, or we can just say raised to the power of 1/4, which is 0.25. This is mathematical in nature, equals 1.012. And minus 1 from here on this side, so I equals 1.2%. 0.012 times 100 is 1.2%. To approximate, that could be 5% divided by 4, which is 0.0125, very close to the actual 1. We can use that for approximation. But then again, because this is compounded interest, that's why it is not suggested for the actual interest rates. Next, for the yield curve, which would show us the grow or the growing money or the growth of the money. And of course, we can see an upward slope to the right for the yield curve, since in the long term, the rates and the rates of returns would basically increase over time. Spot rates, again, are the rates that are current in certain times, and these are charged for loans contracted today. So we have spot rate 1 for 1 year, 2 for 2 years, 3 for 3 years, etc. The yield curve is a listing of current spot rates for different maturities on an annualized basis. Yield means return. So we can basically attach that concept to it so that we will not forget. Now, forward rates, on another hand, are basically the interest rates that are to be applied in the contract in a future time. So example, if we are going to enter into an import or purchase transaction from abroad, when we pay, we are going to use our, let's say, Philippine pesos to buy, for example, United States dollars as denominated currency of the contract. So to pay that, let's say 90 days from now, we are going to pay whatever will be the spot rate or fair market value or current value of the currencies 90 days from today. So that's the point of forward rates. We also have to take note that forward rates are basically based from the current exchange rates, which are normally published on daily basis. However, because the forward rates are done by privately contracting parties, so it's possible that there could be a margin or spread. So the gross profit from trading, because whatever will be the current exchange rates, in order for the seller to gain in the process, there would be something on top. So let's say this is the current exchange rate, but if that particular, let's say, bank or financial institution would be selling the currencies, they're going to charge more, and that will be the gross profit again. So that's business perspective as well. Now for symbols, we have F enclosed in parentheses 1/1, which means that the interest rate on 1-year loans contracted 1 year from now. The 1 here will be the time that we are going to settle the contract, and we are going to apply the forward rates. While the second number would be the term or the time in the contract or loan contract. So example, this 1-year loan contracted 1 year from now. So 1 year from the now or the future, and this is a 1-year loan. For the second one, 1 year from now contracted, and 2 year for the loans. This is 2/1, meaning to say 2 years from now, in the future 2 years from today, and interest rate on 1-year loans. So also another point is that the spot rate 1 is equal to the forward rate at basically the loan that is contracted today, 0, and that is interest rate 1 year from now. So meaning they are equal because the spot rate is today. So basically the contract is also today times 0, but then the rate will be based on 1-year loans. Forward rates are not explicitly stated. As said a while ago, they can be changed or determined by privately contracting parties, but are implied through observed spot rates. So the basis overall will be the spot rates or the current market exchange rates. For calculating forward rates, for example, the current annual yield on a 1-year treasury is 2%, while a 2-year treasury pays an annual rate of 2.6%. So for the $1 investment for 1 year, basically that's just going to be $1. We are assuming here we have $1 as our principal, multiplied by 1 plus I. 1 and then the I is 2% or 0.02. So 1.02 times 1 equals the number, which means that our interest basically for that is 0.02. While if it is going to be the 2-year treasury, so 1 times 1.026 squared, or we are going to have the expanded notation. So that's going to be $1.053 invested for 2 years. And 1.02 multiplied by 1 plus F, meaning the forward, for 1 that is basically the contract, so 1 year from today, and then 1 for the term in the loan, or here treasury, so 1 year. Again, just like here, so F11, 1 is the contract, so the time from today, and the next one will be on the contract itself, or on the, let's say, loan, the interest rate on 1 year. So here, 1 is from 1 year from now, and then that's 1 year, and the next is 2 years. So the difference would be 1 year, and the 1 will be for basically the interest rate on 1-year loans. So that's going to be 1.053. And if we are going to get now the implied return from first year to second year, that's going to be 1.053 divided by 1.02, and we get 1.032 minus 1, that's 0.032 divided by 1 equals 3.2%. That's why, or that's how we are going to get the forward rate. Next would be this example. Let's say 2-year treasury, 2.6%, and 3-year treasury. So same principle. First would be just good for 2 years, so squared, and this one will be cubed. And we get $1.053 and $1.09 respectively. And if we are going to divide, the latter divided by the former equals 1.035 minus 1 equals 3.5%. So that's how we get the forward rate for this example. Then there is a relationship between our spot rates and bond prices. We have to know, again, for zero coupon bonds, they are convenient because they only involve one payment. And basically for zero coupon, coupon stands for the interest. There is no interest, only the payment of the principal at the end of the period. Essentially for bonds, when you are going to think about such, we pay exactly at the end of the period equal to the principal. Face value assuming is $100, so a 90-day treasury bill is currently selling for $99.70. There is a discount of 0.30. And to continue, the yield to maturity, or the YTM, if we're going to convert that, is basically 100 minus 99.70. That is going to result to 0.30 divided by 99.70 equals 0.003 or 0.3%. That's our YTM. If we're going to annualize that, because this is good for 90 days, so that would be 365, though, is used here for actual number of days. So we can also use that to be able to get our annualized rate. So for the annualized YTM, this is our formula anyway, 1 plus our rate to the power of 365 over 90. This is not similar to a while ago for the annualized rate, wherein that is simply 0.003, and then we are going to divide that by 90 over 365. So that's going to be different anyway, right? But then, well, this is 365. That's why we are getting another answer. But if we use, for example, 360, so 0.003 times 360 over 90, or basically 0.003 times 360 over 90, or the reverse of that, times 365 over 90 is actual days. 360 over 90 would be ordinary interest, or we call that the business days or the business calendar composed of 360 days. So again, going back, 0.003 divided by 90 over 360, that's going to be resulting to 0.012. So that's how we are going to get that. Should we use the formula that we have discussed also prior? All right, so I would suggest to use anyway 360 days unless stated in the problem. Now, another mention would be strips, in which these are financial instruments created by the Treasury Department in 1985, which stands for separately traded registered interest and principal. This is very similar to our zero coupon bonds, wherein there's no interest. And then we are going to compute, of course, our YPM. So let's say a 10-year strip is selling for $63.69. And with that, we can compute the YTM by getting our respective discount in this case. So that's 100 minus 63.69, 36.31 divided by 63.69 equals 57.01. But this is basically good for the entire 10 years, correct? What we can do now is really to follow this formula, 1 plus the rate, and then to the power of basically the 0.10. So we can do this. That's 1.5701 to the power of 0.10. Or if we think about it, this is 1.5701. That is 1 over 10, or 10%. And we can go back to the annual YTM that is with that formula. YTM here is actually good for 10 years. So if we want to get the 1 year, that's what we can do now. All right. But anyway, that's still going to be mathematical, or we can simply analyze this one as the 10th root, right? 10th root of our 1.5701 quantity. So you can use your scientific calculators for that one if you would like to get it. It depends, although we can use this particular formula because in discussion of radicals in high school, if you can recall in algebra, remember our respective fractional exponent will have the item on top. Let's say in this case, 1 over 10. The 10 would be our root, and that's a denominator, by the way. And the numerator will be the exponent of the number inside the root, which is, we call that the radicand. That's, again, mathematicals. So discussion in radicals. To simplify, that's what we can do. Okay? Then after this is, for a while, we're done with that, forward rates and bond prices. Strip prices actually imply or also imply forward rates. Example, this is just for August 2014 versus 2015. That's 1 year difference. In 2014, that's selling for 68.07, and in 2015, that's 63.55. So if we divide the two, we get 1.07 or 7%. All right, so that's also what we can do by then. Okay, and then this part here, interest and bond prices, will be tackled in the second part or video of this particular series. Hopefully you get something from this session. Thank you very much and God bless us all.